So last lesson we set up this circuit and we got data for a current potential difference graph for a fixed resistor. And what we had to do is we had to change the value on the power pack to change the voltage, but to get regular intervals we then had to adjust it with this variable resistor here. That's not ideal because we're having to change two things, and in fact if we set this, let's say we've got just an 8 volt supply, why not? It will be impossible to get, it'll be impossible to get 0 volts to start with. It'd definitely be impossible to get 0 volts over here if we've got a fixed supply over here. With ours we could set the power pack to 0, but if we've got a fixed supply here, then we can't do that. So we haven't made a kind of variable voltage supply by putting in a variable resistor in our circuit. There's some limitations to it. We're going to do a little experiment just to have a look at what those limitations are and if we can find a better circuit. Okay, so we're going to have two circuits. We're going to have circuit A and we're going to have circuit B. Circuit A, we're going to have our fixed power supply, and we're going to have our variable resistor as normal. We're going to have our component in here. I'll tell you what, we'll just use the bulb for this one. We can just plug in the that small bayonet cap bulb, or the brake light bulb, you know, the one on the little metal stand that's in your box. And then we won't need any crocodile clips. And we're going to set up this circuit, and we're going to put a voltmeter in here. Right, hopefully we're fairly familiar with how to set this up. This is in fact actually the same circuit as we set up last time. I'm actually going to put an ammeter in as well. Sorry about the bad drawing there. And what I'd like you to note down is the minimum voltage that you can get. We're going to set this. I'm going to set this on 10 volts. Okay, so 10 volts, we have a DC supply. So I want you to minimum voltage and the maximum voltage that you can get, and the minimum current and the maximum current. Okay, so just 4 bits of data. We're not going to plot a graph with them or anything. It's just so that we can compare our two circuits. And then with circuit B, do something a little bit different. We're going to get our power supply. We're again going to set it on 10 volts, so we're comparing them properly. And this time though, we're going to connect the variable resistor so that, do you remember in the last video, or even looking at your variable resistor, I showed you, we've got this tube with all these turns of wire around it. We're actually going to connect both ends of that wire just to the power pack, straight up to the power pack, like this. Right, you might think, why on earth have we done that? Because we haven't put the component in here. Where's the bulb? Well, I haven't finished yet, because that slider, which I'm going to actually connect up here, we're going to connect the slider to one side of the variable resistor. It doesn't actually matter which one. And we're going to put, I almost forgot there again, put an ammeter in here, we're going to put a bulb in here, and we're going to put a voltmeter in here like this. So I'm just going to get the variable resistor and show you kind of how to connect it up in a second, but same as before, for circuit B, I want us to record the minimum potential difference, the maximum potential difference, the minimum current, and the maximum current. Right, so it's same bulb, same power pack, same supply voltage, but a completely different circuit. I'm just going to get the rheostat and show you how to set it up. And by the way, a rheostat is a certain type of variable resistor. I think I said that in the last video, but anyway. Okay, so this is the rheostat. Just going to lay it down on the side. And we've all got a rheostat that's pretty similar to this. I'm just going to label these. This is, I'm going to call connector A. And I'm going to call this connector B. So those are the two at the bottom of the rheostat. And then I'm going to call this one, the rail at the top, I'm going to call it connector C. Now some of the rheostats have got connector both sides, but we can just ignore that last one. And then I'm just going to go back to my other circuit diagram. And I'm just going to point out which label each of these are. So this is A, this is B, and then this one here is C. So that one on the edge of this arrow, look, that's the rail. For the purposes of this circuit diagram, that's how we draw them. If you're using this circuit, because of the convention of drawing these circuit diagrams, we just put the variable resistor symbol in the circuit. That doesn't mean that this is A and this is B. This is A and this is, one of these has to be C, right? One of these sides. It doesn't actually matter about what the other connectors are, but one of these does actually have to be C, whereas in this circuit, it's the bottom of this arrow that we call C. So it's just a convention, I'm sorry about it, but for this circuit, right, we're going to use all three connectors on our rheostat, and then we're going to get a minimum, maximum currents and potential difference data, and hopefully you'll be able to see that one is more useful than the other.